every object has a mass. Something like extracted teeth is located here. We weigh on the scale and it gives you a weight. Okay? But weight is different according to the place it is. On the Earth, it has a weight like that. But if it is on the Moon, weight is decreased because weight is a force between two objects. In a space, it doesn't weight is zero here. Okay. So the weight is different, but the mass is the same. Okay. There is a point that all the mass is concentrated in a single point. It's called center of mass. Here is a tennis racket. Throw it. It gives you a projectile motion. But if you focus on the handle, it gives you very weird movement. It's called cycloid. However, if you consider the center of mass, it gives you exact parabola. This is called the center of mass. So when we throw something, we all learn that it gives you a parabolic projectile motion, but actually where you see is different. If you see at the handle, it's not a projectile motion at all. It's very weird motion. But we say that these tennis rackets, all the mass is concentrated into the single point, and that point gives you a projectile motion. Right? So that's called center of mass. When force is acting on the center of mass, it translates. Translation means all the point of the object is moving into the same direction, same amount. Like this, it's called translation. Or in orthodontic term, it's called bodily movement. But this is an extracted teeth. We do not deal with this extracted teeth. The teeth that we are dealing is inside the periodontium, in the bone, and the movement is constrained. Okay? So, the constrained movement, if you apply the force at the center of mass, the bone or periodontal ligaments inhibits the movement, so it tips, doesn't translate. Okay, so if you move the force downwards over here, it's going to, root is going to move rather than the crown, something like this. Okay? So up here, it moves, but tips counterclockwise. On the force on the root gives you a counterclockwise tipping, so that there must be some place that it translates in between, something like this. If you apply the force, it's going to translate, and this point is called center of resistance of the tooth. The point where we apply the force and teeth going to translate is called the center of resistance. Here we have a book on your desk. We will have a simple experiment over here. Can I use this book? Now, if you apply the force here, it's going to rotate it. If you apply the force over here, it rotates it backwards in opposite direction. It's somewhere in between. If you apply the force, it's going to translate. The center of resistance over here, because this movement is constrained by the friction between the book and the table. So the friction is like a bone in the tooth. So if you apply the force at the lower side, it's going to tip like that. Okay. But if you apply the force near center of resistance over here, it's going to translate. And you can see that center of resistance lies somewhere in this line over here. Okay? That's the location of center of resistance. how do we know? How do we find out where the center of resistance is? The movement of teeth is very small that we cannot see. We don't know if it is tipped like this or tipped like this. We cannot distinguish by naked eyes. So we use laser pointer. This is maybe not be interesting to clinicians, but I'll explain how we discover center of resistance. Now, we put the little mirror over here. Here is a mirror. And we shoot the laser pointer. Do you see that when you make a presentation, if you make a presentation for the first time, laser speckle moves very, very hard because you're shaking hands, right? So that means very small movement is very amplified with a large distance. So that's why the speckle is shaking a lot. Now we use a laser pointer to reflect the light, and we have a very long distance. Now we apply the force over here, and it tips so that the laser speckle moves up. So the movement is still so low that we amplify it by many arrows like this. With very small tipping, this laser speckle moves up. So we can see that it is been tipping to this side. Okay? Now, we put the force down, and it tips like this, and laser speckle moves downwards, so that we can now see where, if we apply the force and the laser speckle does not move, that's where center of resistance is. This is called laser reflection technique to find out the center of resistance. There are many other methods to use, but this is very interesting and very easy to understand to find where the center of resistance is. Now, in the molar, in the lower human mandibular molar, center of resistance lies in the furcation area, some place like this. So if force is acting downwards or upwards, then the rotation goes, the degree of rotation changes like that. So in on human mandibular first molar, center of resistance is at bifurcation. And center of resistance is, as you might notice, center of resistance is depicted in a circle, not a dot, or an area, because center of resistance is a little bit direction sensitive. So in recent studies, center of resistance is not a point. It is like an area, so that I depict the center of resistance as a circle, not a dot. This is another example of how to find the resistance. Well, anyway, now we find the resistance for the first molar. It's located in the bifurcation area. And you apply the force over there, the tooth is going to translate. Okay, that's called primary tooth movement. First primary tooth movement is a translation, and translation is caused by force applied at the center of resistance. Okay, there are many studies that indicates where the center of resistance is. But roughly speaking, center of resistance lies 1/3 of the length measured from alveolar crest to the apex. So 33%, 1/3 of the root length is where the center of the rotation of a single tooth is. In the molar, it's in the furcation area. In a single teeth like incisor, it is at 1/3 distance from alveolar crest. So those are the places where center of resistance is. If you apply the force over there, teeth is going to translate. Now, as I said, alveolar crest, not the CEJ, so that if alveolar bone losses occur, center of resistance moves downwards. So in adult patient with a low alveolar bone level, the center of resistance much located apical, moves apical than adolescent patients. So for young patients, center of resistance might be here. With older person, center of resistance is located downwards like that. Okay. You can easily see that the center of resistance over here, but the book is moved and alveolar bone losses happen over something like this. The center of resistance moves downwards. Center of resistance moves as a parallel. It depends on periodontal support, not a unique area. we apply the force at the center of resistance? Center of resistance is covered by a bone in gingiva, so directly applying the force at the center of resistance is very easy, very difficult. Here we have a crowded patient, and obviously this is an extraction case, but as you can see, the first molar has a defect of the crown, so it's a resin. So I decided to extract the first molar. After extraction, I put the lingual arch over here, one at the molar, and the other, an anterior lingual elastic at the premolar area over there. And there is a hook. Now, let's say we took a lateral ceph of this patient, and this location of this hook is about the center of resistance up high in the palate. If the palate is high enough, you can place the force very up near the center of resistance, so that anterior and posterior moves in translation. There is no tipping, so that first molar space is being closed by second molar over here, and as the second molar moves forward, the third molar erupted into the second molar area, so that it might look like a non-extraction case, but actually this is second molar and third molar. So how did I make this translation? I put the force at the center of resistance, not at the crown. So the translation occurred. Here is the before, here is the after. This is the second molar. This is the explanation of the why center of resistance is in an area. If the support is something like this, center of resistance is not a unique point, so I draw it an area or a circle. I will not explain detail about this. Now, will the location of center of resistance depending upon the magnitude of force? No. Even if you, let's say, someone says if you have a tip to teeth, and someone might say the extraction space has been tipped because you use heavy force. Light force will translate, heavy force will tip the teeth. No, that's not true. The location of center of resistance is independent from the magnitude of force, and even if you use a small force or large force, translation occurs, provided that the same location is used as a force. So force location is, if the force is acting upon the center of resistance, the magnitude of force doesn't matter. The 50 gram will translate, and 250 will translate also. The location of force is important, not the magnitude. Shall we have a break? It's a little boring, but